Hey, Justin,
Yes?
have you ever heard of a muon?
No.
Well, that's what we're talking about today, baby. Are you ready?
I guess so.
All right, well,
Yeah.
before we get into that, it's shill time. Shill, shill, like, subscribe,
Should
share, comment.
I,
This is a
should I,
science video, and
should I
I'm
donate?
sorry. I'm very sorry. But it'll be cool. And if you like physics, or if you don't, you're either going to love or hate the topic of this video, depending. Now, are you ready to get into it, Justin?
Yeah.
All right. Well, we're going to start by talking about muons. I need to put my mic down for this.
Oh.
Where's my fucking pen? Here it is. This is chaotic as shit. Okay, let's ready this. So
Uh-huh.
we all know what an electron is, right? We got that. We understand
Yeah.
that. That's a
Uh-huh.
concept we get.
Yeah.
Now, an electron is only one of many small elementary forces in the world, in the
Uh-huh.
universe, even.
Mm-hmm.
We have the Higgs boson, we have protons, neutrons, neutrinos, etc., etc. A lot of shit. Now, a muon is one of those. It has all of the properties of an electron, except two things are changed. One, a muon is 200 times as heavy as an electron. And
This is a
two,
science wait. Is this a science video of you just explaining how you could survive being stepped on?
no, because I don't want to survive that. That's just true. No, but a muon is also self magnetic. What that means is it essentially acts as though it has a tiny magnet inside of it, microscopic even. And when it's introduced to a magnetic field, it gains a property called spin. Now, Justin, can you guess what spin is?
When you spin, you spin. So,
Exactly.
so when you
My
rotate
assistant, everybody.
when you rotate around and around and around and
Super
around
fast.
really fast, yeah.
Now, it spins somewhat like this, according to what I have seen, which has been a solid 15 minutes of research before sitting down and recording this video. By the way,
Whoa. How crazy.
full 15. But as it spins this way, it has a standard deviation, which is what we're talking about today, of give or take, to the trillionth place, 2. Nice and easy.
Hmm.
Now, that standard deviation of 2 was challenged in 2017 when a group of scientists in New York decided, hey, we should study what the fuck a muon is, because we have no idea. Now, they had theorized, and to the most part, all of the theories have been correct. Higgs boson, neutrino, all of it, standard deviation, we got right. We theorized about it before we knew about it, etc., etc. We understand. We've been new.
Mhm.
But then something happened. And this is where we get to the topic of today's video. They discovered a slight deviation in what they observed. That slight deviation was incredibly small. We're talking like, okay, imagine measuring a football field for all of you Americans out there. For the rest of you, fuck, dude. Look up what a football field is.
Just use the metric system. It's okay.
I don't know the metric system conversion for a football field.
I don't know either.
Well,
uh,
fuck.
uh, uh, take a step outside and then bring out your cubic ruler, and then when you take a step, measure how much that is, and then
A foot
etc.
is 12 inches. An inch is roughly 2.54 centimeters. A yard is 3 feet. A football field is about 140 yards if we include end zones. If we don't, 100 yards. Easy. Us Americans, we understand.
Ah.
But basically, you're measuring that with something smaller than the width of a human hair.
Mm-hmm.
That is the deviation we're talking about. We are talking about infinitely small. Now, you may be wondering, Jack, how the fuck did they measure that? That seems impossible. Yeah. Yeah, no. Yeah, no. That's right. However, science has advanced to the point where we can do shit like that and just pull it off, and it's fine. It's fine. Now, the way they did it, getting into the boring stuff real quick, they basically made a giant fucking magnet in the shape of a letter C because C is for cool guys. And they piped in so much magnetic force, about, a couple hundred times more than the magnets you find on your refrigerator, if you still do that. And they pumped in a bunch of muons and just watched them and measured them.
Mm-hmm.
That's it. That's how they did it. That was done in 2017, somewhere in New York. Then, last year, the year of our Lord, Satan, 2020, in June, so after COVID started, they brought in that giant fucking C-shaped magnet. Just carried it like, I don't know, 3,000 plus miles to Illinois, wherever Illinois is. I don't remember. That's
Yeah.
not a joke. I'm bad at, I was about to
I
say
don't know.
geography.
Yeah.
They brought it all the way to Illinois, plopped that sucker in the ground, and decided to repeat the experiments. After a year, they discovered something very interesting. That new standard deviation, which should not be there, by the way. We're talking about things that, like, ugh, dangerous, bad. Well, not dangerous, but like dangerous for physics students, if you know what I mean.
Oh, crazy night on the town.
And they found that that new deviation in that first test was correct. Now, this doesn't sound as exciting as if I were to just say, they found a new fucking form of physics. But that's basically what they did. Not yet. There are going to be 5 more tests over the next 2 years or so, by the end of 2022, to see if this is correct, to see if what we are doing is right. And if it is, that's a new form of physics, baby. Oh, yeah. Essentially, what that theorized form of physics is, involves a type of particle called virtual particles. Justin, do you happen to know what a virtual particle is?
It's a particle, but virtual. Yeah.
You're shockingly not far off.
Yeah.
Like something with the name virtual particle, you'd expect, something not virtual. But essentially, what a virtual particle is constantly around you, just popping into and out of existence, like a snap, like that, gone.
Tune. We're gonna make it to the tune world, baby.
Yeah, pretty
Space
much.
Jam in real life.
Basically, every tiny particle just snaps into existence and immediately snaps out. Because as that particle spawns in, antimatter spawns in alongside it. And when matter and antimatter meet, it's total destruction. Nothing is left. Which challenges the known physics of the world that matter cannot be created nor destroyed. Same with energy. It's very interesting, but, that's getting off on a tangent. Basically, what's theorized is that those virtual particles are popping into and out of existence around the muons. And when it comes into contact with that muon, it sets it off deviation that much. And we've been able to measure that. And if that's right, we're going to have a whole new thing. Now, what's really interesting about this is that when it comes to things like, say, the Higgs boson, or the neutrino, or even the muon itself, we had theories surrounding them prior. We had the idea that they existed. But this new, possibly new physics, we had no fucking clue. This is uncharted territory. This is brand new. We are living in a cutting edge era of physics. And what that could possibly mean for the future is, you know, if you want to take my word for it, faster than light travel. I can explain that later, but for now, I feel like I've overloaded enough people's brains, so this is the end of the video.
Space Jam.
Space Jam! That's it. Love you all. Thank you for watching. A science high school student trying to explain the muon G-2 experiment.
While wearing cat ears.
While wearing cat ears, as is fucking proper. Thank you so much. See y'all next time.